All right, so when in your mind, when you have like concepts or like any sort of knowledge, you have it in like a crazy structure, right? Your beliefs are a network of connected things, and you know they're concepts built out of smaller pieces. There's like nebulous overlap and all sorts of stuff like this, but like these are the things that are inside a human mind, right? Like kind of looks like that. But when people talk, they have to talk in just like a stream of words to another person. And the way that we have of representing knowledge often is like either like a long form video where someone's ranting at you about a thing, or more historically speaking, you've got like long strands of text, right? And this goes on for, you know, books and books and books and books which are footnotes of other books and books which are based off of knowledge in other books, right? But this knowledge is, let's say, poorly structured, because, you know, think about any given news article or something like that. You'll have, let me change the color. You'll have claims down here which are dependent, you know, like they're based on assumptions that were like articulated up here. You'll have like other claims that are based on other things. I mean, this is just for argument structure, but like you could also think about it for conceptual knowledge, where you're, you know, defining a term, or you're talking about the context in which something is applied. And so, yeah. One thing that I've noticed in terms of the various ways that people, so first, like this is particularly a problem for knowledge transmission, but it's also a problem if you wanted to parallelize work. If you were trying to get a bunch of people to explore conceptual space together, like if you have, you know, like multiple people, right, who are all trying to like, if you've ever been in a, you know, like a Google Doc trying to like solve a problem with folks, it's a mess. Like there's a lot of things that you can't write together, because, you know, you have to figure out how the structure of where to order things. Like there's all sorts of different ways in which like the graph can be linearized. This is a, you know, a complicated data structure that you have, and it's dependent on what the purpose of the communication is. Like trying to transmit this thing, this thing can convert into like, you know, there's all sorts of different ways that you could decide which sections of it are relevant. You know, in one context, this section is relevant. In another context, like, I'm just gonna, like, this section's relevant. In another context, you know, like, this whole section's relevant. And you decide which of those two to introduce first, right? So there's all sorts of different ways that you could linearize it into prose. And there's, like, context dependency, there's all sorts of things like that. And that becomes a problem both for knowledge transmission and for parallelizing and getting a bunch of people to be able to think together where they can each take a different part of the problem, but still have a cohesive sense of the whole. So how does this connect around? Like, when people are writing just for themselves, pointers to something, single word notes, you know, or like, you know, partial phrases, and these things are basically just intended to be pointers into their own memory. You know, I'll use a different color. Like, yeah, we'll use purple. So these are just intended to be pointers to something that they already know, and that's not particularly useful for transmission. It's not particularly useful for parallelization. A step above this is, you know, for somebody to start writing in like complete sentences or paragraphs, you know, right? And that is what most companies are doing, like most of the way that people are when they think about, I'm going to solve this thinking problem with somebody else, you know, they're thinking about writing long documents. The problem with this is that any person who wants to get up to speed on the thing, even if this person, you know, basically they've got a particular set of expertise on like a multi-dimensional problem, and you want them to be able to give you feedback on like the one area where they have expertise and a ton of leverage on the problem, and that might be this thing right here, right? Or like that was a bad, like, let's say, well, I fucked it up. Whatever. That would have been, that's a better, in this big document, the thing that they are, that their expertise is going to be relevant on is like that section. But that section, in order to like make any sense of this, they have to read like a little bit of here and like a little bit of here, right? And so when you're transferring knowledge with documents or with prose, it's possible to do it, but often the person has to read way more information. All this other stuff, all this stuff here is like irrelevant for them and more likely to be like cause of distraction, like sometimes the full context is needed for the problem, but it's a thing that we should be somewhat intentional of and aware of, like how much context is necessary for somebody to be able to participate or help on this kind of thing, especially when you're trying to think about parallelizing a problem to tens or hundreds of people, or like people with very different expertise, with very different conceptual knowledge. Like, these are all potential minefields where somebody could get distracted or lost, or like it also just takes a lot more time. So one of the first things that we're trying to establish in Roam is how do you take something that's written in prose and extract it out into a data structure that allows for more efficient allocation of attention, both for transferring knowledge and for parallelizing complex problems that require like interdisciplinary stuff. And that's useful, particularly if you want to take a mental model from some other foreign discipline, and like that might be useful for solving your problem. There's a great example of Albert Einstein, needed a mathematical language to describe like the ideas he had around gravity, and he didn't have it, but he had a friend who knew about Riemann geometry, which is a relatively new branch of mathematics at the time, and that friend was able to point him to just the tiny set of math he needed to learn. He didn't need to go spend 20 years studying all of mathematics. He could go study this particular set of like descriptive equations and thereby create the, special relativity and general relativity. So we want to make those kind of serendipitous connections that allow for massive insight and like leverage over the world and your problem space more actionable. So one thing that I've if you're thinking about the progression of someone as a like Roman in the team, right? The default thing that we should be expecting is that many people, when they they don't even take notes at all, and when they do, they're like a handful of notes that are just designed to jog their memory, right? The next, the next stage, right? So this would be like, I'll just, but this is, we'll call this like pointers to memory. This is what most people think of when they think of notes. It's one of the reasons where like it's difficult that we used note-taking as the initial metaphor for our target market. It's like, but this is something that people are familiar with. Roam still helps with making the pointers more accessible in more different ways, even if you're just taking notes like that. It does still help people a lot, but that is not particularly useful for the augmentation of collective intelligence, especially where you need to transfer knowledge or you need to parallelize things. So the next level that you see when people, and this is something that we often see when we're trying to find good writers to work at Roam, is they're at least thinking about trying to like lay out reasoning in a sensible way, and they're writing prose that is like, if you read the whole document, like there's coherent arguments, there's like, they're separating out mentally the chunks, and they're doing a good job of like carving reality at the joints as best as possible and like laying out the conceptual states, but they're doing it in sentences and they're doing it in paragraphs. And this is almost all the primary source material that we'll get in blog posts or YouTube talks or whatever, right? So one skill that we have to develop, and this is part of the Roam canon onboarding process, this is like the gen ed requirement for everyone who joins the team. And we've got like, as an example, I'll give a quick example, like for many years, right? If the way that mathematical knowledge was transferred was in paragraphs, right? And there was a big innovation in the writing of papers when they started writing proofs as sort of like numbered sets of claims, and saying like, like some sort of like dependent structure on these things, right? But even mathematical proofs don't have sort of a ability to sort of like scan a logical structure and say like, this claim is based on these two, this one is a separate claim that's based on these two, right? And like these two combined plus this one over here will give you like this conclusion, right? There's like a way in which you can, and so far, philosophy departments at universities will try to do basic things like argument mapping, where they're sort of imagining things as just having a structure of like pros and cons, and they'll visualize sort of like arguments against something. But that also is this is one kind of compression that's doable. So but it is limited in its application for parallelizing problem solving, and it is a poor description of reality. So it is a lossy data structure. It is one where lossy compression is basically where you lose information in the transformation process. So like there's this doesn't handle things like, well, in this context this works, in this other context it doesn't work. So argument mapping, or like these two people are using the same term but in different ways, and that's why they're disagreeing. They don't actually disagree about any objective fact. They disagree about a definition of terms that relates to some word that's being used in one of these. Like there are many other ways of parsing stuff. So the first part of the Rome canon process that people will go through, information that is stored to take information that is stored in a flat serialized string data structure. It's stored basically as a continuous. It starts at point A and it just goes, and there's no structure to it. One of the first things that we'll have you do is like a sorry, I should have used a highlighter, right? Is like this highlighting activity of basically just pulling out interesting bits, right? And this is starting to, when you've pulled out those interesting bits into new blocks, right? Each one of these becomes their own discrete unit. The first activity is just extraction of discrete things, and the second thing that people will do is take those discrete things and start to turn this into a structure that is using, turning it into a data structure. So one example might be, you could think about how a question has potential answers, right? And how if you think about a statement, right? There's a quote I love from James Baldwin. It says, the purpose of art is to identify the questions behind the answers we take for granted, right? Statements that we just accept as true often are a combination of a particular question with a particular answer, but those both kind of get hidden behind a statement, which is, if I said, like, Kersey is the best pope for in-group Twitter, right? This is a statement of fact, because that is objectively true. But it is actually also you could parse that statement, which says, Kersey is best in-group pope, right? If you deconstruct that, you could say there's the question of, it says best. There's the question of in-group pope, and then there's Kersey, and so this can become a question which says, who is best in-group pope, right? And then the particular answer of Kersey, right? If I said Kersey is best in-group pope because these things, I'm also saying that, the reason that Kersey is the answer to this question is these statements, right? So this just is one example. The relationship between question, answers, and statements is one example of how structuring knowledge is its own kind of programming activity, because you even have to make a decision of, do I write question and answer? Do I write a statement as a statement? How does that relate to how much time I'm putting into the problem, how much effort, how articulate I want to be? This statement of who's the best in-group pope might be easier for you to parallelize or break into chunks that you could address one unit of attention at a time. If, for instance, you were saying, okay, these are the reasons Kersey's the best in-group pope, and this one is like that eel woman, right? Or dude who bought votes, or the mechanical monk, right? If you start to structure it in a different way, it's easier to start doing this comparison, and then you might even go out to this statement of best in-group pope, and that can be extracted into what are the characteristics of in-group pope that would make them best, right? Depending on how thoroughly you want to investigate the question, you may deconstruct these kinds of things into, potentially a larger question like what makes the best, and then based on traits that I might, and then I might say, okay, from here I'm going to ask what are the traits of Kersey versus the eel woman, and how do those traits match up to my idea of the best? This is an example of knowledge structuring, right? So the first stage is to just do simple extraction. The second stage is we will give you various templates of so another metaphor that I'll throw in here is that the world is like, I don't know. The world is like a messy, nebulous place of all sorts of things, and anytime you're looking at the world, you are. This is where that Pasteur luck favors the prepare and bind question comes in. Or you could think about the Feynman historically had 7 questions he was interested in at a given time, and anytime he had a new observation or he had a new mental model or a new mathematical technique or a new idea from physics or some other discipline he was learning, he would apply a lens over the new. He would basically throw that new tool he had against his existing questions and see if they yielded any insight. And so one way of thinking about this is that there's various lenses you can have over the world that will cause you to notice different things depending on what your perspective is. And so the second stage of the Rome process is we give you examples of these templates. Like I'm going to go through and I'm going to find the lens I will apply is what statements in this are statements I disagree with, right? Or I'm going to go through this essay or this talk and I'm going to say what questions is this person trying to answer, what terms is this person defining, what statements of truth are they, what are they claiming to be true, right? That compression activity of saying someone gives someone has an essay and you just say, well, what are they saying is true as facts, right? And they might not have to, you might have to write new words that they didn't write in order to say it because they're saying it across 4 or 5 different paragraphs, but really you're compressing it into through a different lens. So first is going to be doing that. Eventually, the movement in Rome, right, is to go back to this well, maybe I should go. I'll continue, right? So first we start with having, not just writing notes, right? But someone may do this. We're going to try and skip over this a little bit because we'll use existing resources to teach this separate skill that is very rare because there hasn't been a medium for this kind of knowledge before. Many people have learned to write, some better than others, some have practiced it. But thinking about the geometry of the thought, the geometry of the knowledge, and what are the pieces of knowledge that are here and how they relate to one another, and also from even an abstract term, how are they? We will give you geometry patterns to apply, and the next stage is looking for a particular pattern that exists, and then the third one is basically coming up with these yourself. Sorry, I shouldn't have used this drawing. So the next one would be basically writing these things out. And then the 2 following stages from that, which Rome as a tool is particularly trying to do, is to on the more technical side, Rome has properties that no other application has in terms of user extensibility that make it so that you can, with a relatively small amount of technical knowledge, create totally different experiences of interacting with that structured data, of allowing you to do things around, the simplest is using the tools we already have, like querying, and different view options that we have for tables or those kind of things. But the whole purpose technically for us in building a programming language of human attention and using that to create an operating system for collective intelligence is that the next stage is somebody coming up with these templates of their own. The stage after that is modifying Rome itself to do things like I might say my statements are all of truth are all going to be green, and I will put red stuff underneath them for things which might refute them, right? That is actually a very easy thing to do using some CSS tags that are already part of Rome. So that's something but as people develop in their engineering, they can do crazy things view things as a chart or as a higher dimensional interactive space that allows them to filter through constraints on a problem and see which of the potential solutions is still relevant to the problem space if they adjust their constraints, and creating whole new experiences out of that structured data. But the ability to even think about what features are useful for this stuff requires thinking about the structure, out making an authoring space that allows them to filter through what features are useful for this stuff requires thinking about the structure of your knowledge so that you can then design experiences that allow you to interact with these these things are all about, or I would say all of one way to think about all of web applications or phone applications right now, because it is all just fancy screens, but every application, Facebook, Twitter, all these things you use, what they are actually really is context sensitive information graphics. If you are filtering your shoe options from Amazon, you are basically creating a dynamic information graphic based on your shoe size and the price that you're interested in, the kind of shoe that you're interested in, that kind of thing. So context-sensitive information graphics, MapQuest or Google Maps is a context-sensitive information graphic that is drawing you the map based on data that you've put into it, right? And so Rome is about making an authoring platform for these context-sensitive information graphics that allows you to explore conceptual space the way that MapQuest or the way that Google Maps takes all the potential routes that exist in the world for, like going from point A to point B, and it allows you to view just the information that's relevant to use in an actionable way so you can get driving directions. Roam is helping you, it's a different kind of tool because it is just as much for the creation of maps as you are exploring the space as it is for just helping somebody navigate. That is why our astrolabe is our logo, is because it is one of the most ancient devices used for like having a general abstract understanding of the relationship between humans and the stars, so that you could create maps as you explored new territory, and you could know generally where you are and relate yourself to Mecca or to your home. So Roam is like trying to help people create these maps, and this is the skill that we're going to be trying to instill in you, and and you're going to be part of as well. Everyone is. We do not yet have a map of how, of all the kinds of skills here, right? And we definitely do not have a map of the most effective exercises that will hone those skills and transfer those skills and develop those skills and train people in the act of map making and then the act of building apps for using maps, right? But that is that's the project over the next few weeks.